Imagine you have to move families across an ocean. There are children in the migration and women of childbearing age. You have no chart, compass, or forecast. Some crossings reveal land on the horizon. On the hardest route, the final shore cannot be seen from the beach at all. Today you tap an island on your phone and instantly know the route, the crossing time, and what the beach looks like. Somebody has already been there, named it, and left a review of the nearest cafe. Now delete all of it. Delete the coastline, the island's name, the satellite images, and every reliable account of the far shore. That blank screen is the best map our species possessed for most of its history. No coastline drawn by a returning sailor. No mark showing where fresh water waited. No warning that the current between two islands moved faster than a person could paddle. And yet sometime between roughly 50 and 65,000 years ago, people crossed the deep channels east of Indonesia and established themselves on an entirely new continent. How did they do it? Late Pleistocene Wallacea was warm, rich in fish, and wrapped in reefs. The archaeological record reveals no clear catastrophe forcing people out. What drew them onto the water need not have been desperation. Even paradise has a ceiling. A reef feeds only so many people, and the next island may offer better stone or fresh territory. Then there is the motive no model can measure. Something in us seems unable to leave a horizon unanswered. But to understand the risk, you need the map as it looked then. Sea level was roughly 75 to 85 meters lower than today. Sumatra, Java, and Borneo formed Sunda, while Australia, New Guinea, and Tasmania formed Sahul. Between them lay Wallacea, a maze of islands divided by channels so deep that no ice age fall in sea level ever turned them into dry land. Homo erectus lived on Java for hundreds of thousands of years without reaching Sahul. Earlier hominins reached Sulawesi, Luzon, and Flores, but left no clear evidence of repeated, planned, long-distance crossings. Surviving adrift is different from choosing when to leave, holding a course and moving enough people to establish a population. By at least 50,000 years ago, that difference mattered. This was not one heroic launch. Demographic models point to coordinated movement over centuries. Cross a channel, establish a population, then continue east. The number of passages depends on the route. All required several crossings of roughly 20 to 30 kilometers, and at least one approached 100. With favorable timing, the northern passages could take 2 or 3 days. The harder southern crossing could take 3 or 4. That meant nights at sea, without lights, an engine, or, on some routes, a visible shore. Once darkness fell, the world narrowed to the hull, the next paddle stroke, and the movement of water beneath it. A few degrees of error could become tens of kilometers by morning. For much of the 20th century, researchers favored a simpler explanation. People went fishing, a storm swept them away, and they washed up on new land by accident. In 2019, Michael Bird's team tested that idea in a paper titled Early Human Settlement of Sahul Was Not an Accident. They modeled currents and monsoon winds, released virtual vessels from 17 points, and ran hundreds of thousands of simulations. Every route contained a bottleneck. The chance that a random 4-day drift would reach the necessary shore was between 0 and 6.5%, even without deaths at sea. Once demography was added, the accident hypothesis became extraordinary. To push the chance of avoiding extinction above 80%, the northern route needed about 50 adults washed away every 7 years. The southern route needed 60 to 70 every 4. That is not an occasional accident. It is a demographic leak large enough to drain the source communities. Then the researchers gave the virtual travelers 2 simple abilities: choose a broadly favorable time to leave, and make a small amount of progress in a chosen direction. All it took was half a knot, about 0.9 kilometers an hour, several times slower than walking. At sea, speed matters less than steady movement in the right direction. With favorable timing and that modest directional progress, success rates rose sharply. Remember that half a knot. It comes back later. In 2020, Yusuke Kaifu's team tested drift in another sea. releasing satellite-tracked buoys between Taiwan and the Ryukyu Islands. Of 114 buoys entering the Kuroshio, only 3 came within 20 kilometers of the central and southern Ryukyus. Accidental arrival was not impossible. It was simply a poor explanation for a route people completed 30 to 35,000 years ago. 2 C's, 2 methods, 1 conclusion. Currents can help a voyage. They are not enough to explain a sustained migration. If people crossed deliberately, what were they traveling in? The oldest surviving boat is the Pes canoe, a hollowed pine trunk about 10,000 years old, still far too young to tell us what carried people through Wallacea. That gap is a problem of preservation. Wood and bamboo rot. Fiber disappears faster. Much of the ancient coastline now lies offshore beneath tens of meters of water. The boats disappeared. So did a technology that may have mattered almost as much as the hull. Rope. In 2013, archaeologist Jane Baum argued that fiber technology was central to early seafaring. A dugout could be carved from one trunk, but rafts and composite craft had to be bound together. On a raft, one failed lashing could turn the boat back into a pile of logs. The same knowledge made nets, lines, baskets, and straps. It was learned through touch, how tightly fibers could be twisted, where salt weakened them, and which knots held when wet. A voyage depended on specialists whose most important products were the least likely to survive. At a Neanderthal site in France, archaeologists found a fragment of 3-ply fiber attached to a stone tool, dated to roughly 41,000, 52,000 years ago. It is not evidence for Wallacean boats. It shows that complex cordage is ancient, and that very little of it survives. If you cannot excavate the boat, the next option is to build one. That is what Kaifu's team did while studying the crossing from Taiwan to the Ryukyu Islands around 30,000 years ago. They first tried rafts. The prototypes were too slow and fragile, so the team published the failure and changed its hypothesis. Using replicas of 30,000-year-old stone axes, they felled a Japanese cedar and hollowed it into a 7.5-meter boat named Sugime. On 7th July 2019, 5 paddlers left Taiwan for Yonaguni Island, about 225 kilometers away. Between them ran the Kuroshio, one of the world's strongest currents, moving faster in places than 5 people could paddle a loaded dugout. If they aimed directly at Yonaguni, the current would carry them past it. They had to point toward empty sea and let the current sweep them sideways to the island. Sugime carried no GPS, compass, or chart. The crew used the sun, stars, swell, and judgment, while a support vessel followed for safety. They paddled for more than 45 hours with Yonaguni below the horizon for most of the crossing. On the final approach, they saw its modern lighthouse. Then, daylight revealed the land. The results appeared in Science Advances in June 2025. The lighthouse prevents this from being a perfect prehistoric recreation. But before seeing it, a Stone Age-style dugout had survived 2 nights, crossed a major current, and reached the island's vicinity by human power. The modern light helped with the final identification. It did not paddle the previous 200 kilometers. The experiment did not recreate the voyage to Sahul. It removed the objection that such travel was simply impossible. If you're still watching, hit like. It costs nothing, but it helps other curious people find the video. One boat can complete 1 crossing. How many people does it take to found a population that lasts? 3 model-dependent approaches have tackled the question. Mitochondrial DNA has been used to infer at least 36 to 50 founding maternal lineages. One demographic conversion placed the corresponding population at roughly 720,000 people. In 2013, Alan Williams used more than 5,000 radiocarbon dates to estimate an initial population of 1,000 for 3,000. In 2019, Corey Bradshaw's team modeled hunter-gatherer demography and estimated about 3,300 to 1,550 founders, arriving in groups of at least 130 over 700 to 900 years. These estimates do not amount to a prehistoric census, but their shared message is hard to ignore. One family drifting ashore is not enough. A lasting population required repeated arrivals across generations. That changes the human picture. A viable migration needed women of childbearing age, different generations, and the skills to build a community. A crossing transports more than paddlers. It transports food finders, carers, tool makers, weather readers, and teachers. A population survives not because every person has the same skill, but because different people carry different pieces of the solution. History remembers whoever held the paddle, but the paddle moves the boat only while the rope keeps it a boat. At Majid Bebe in northern Australia, excavators dated the earliest layer to about 65,000 years ago, though that date remains debated. It contains grinding stones, ground edge hatchets, ochre, and traces of seeds, tubers, and pandanus fruit, including Australia's earliest evidence of seed grinding. These finds are not a passenger manifest. Tools could be made after landfall. That is the point. The most valuable cargo was not an axe, but the knowledge to make one and turn a new landscape into a home. Now imagine day 2 of one of the longer crossings. Nothing around you but water, no lights, perhaps no visible shore. No fixed point to show whether you are closing in or drifting away. Nobody sustains a maritime tradition on luck alone. To survive, people learn to read the ocean, and the sea is not empty. Start with the sky. Land heats faster than water, so air above an island can produce a distinctive cloud pattern. From far away, the cloud may appear before the land. The navigator is not looking for a magical cloud that always means island. The skill lies in recognizing a pattern that does not behave like the rest of the sky. A bright, shallow lagoon can sometimes cast a greenish reflection onto cloud. An unusual patch of sky becomes a clue. Then there are birds. Seabirds leave land to feed and later return, so their direction can offer a clue. Some Pacific navigators carried birds to release at sea. One that flew away could suggest land, one that returned to the boat suggested open water. But the most dependable reference may be under the boat. Long swells generated by distant storms can hold direction for days. Felt against one side of a vessel, they become an invisible compass, usable after dark or beneath cloud. The eyes can lose every landmark while the body still feels the same rhythm striking the hull. Land changes waves. Swell bends around islands, reflects from them, and interacts with incoming waves, creating patterns beyond sight of shore. In some recorded traditions, navigators lie against the hull and sense those patterns with their whole body. These methods come from much later Polynesian and Micronesian traditions, not direct evidence from Pleistocene Wallacea. We should not copy a later navigation system backward through 50,000 years. But these traditions demonstrate that ocean signals are real, repeatable, and learnable. They establish the more important point. The sea carries information. People who depend on it can learn to read it. How early had that learning begun? Part of the answer lies at Jerimalai, a rock shelter on Timor. Archaeologists recovered about 38,000 fish bones from nearly 3,000 fish in layers dating back as far as 42,000 years. Many remains were scombrids, the tuna and mackerel family, but could not be identified to species. Deep water reaches close to Timor, so they do not prove journeys hundreds of kilometers offshore. They do prove active exploitation of a demanding marine environment. People knew where fish could be caught and how to bring them home. Jerimalai also produced shellfish hooks dated to around 23,000, 16,000 years ago. They do not reveal how the earliest fish were caught, but show a long specialized tradition. People at Jerimalai turned the sea into a source of life. Such experience reveals patterns in clouds, birds, currents, and swell that remain invisible to an outsider. Once land disappears, the thing most likely to kill you first is not hunger. It is thirst. You are in the tropics under hard sun with almost no shade. During heavy work and heat, the body can lose close to a liter of water an hour. Seawater is too salty. The kidneys need additional water to remove that salt. Long before collapse, dehydration damages judgment, and one bad decision can send a boat past its shore. So make a simple planning calculation. 12 people expect a 2-day voyage, but provision for 3. At 4 liters per person per day, they need 144 liters of water. That is 144 kilograms, roughly 2 adults who do not paddle, and 4 liters under hot, continuous work is still a hard daily ration. This is an illustration, not a recovered manifest, but every planned voyage faced the same problem. Freshwater needed containers. Gourds, bamboo tubes, skin bags, and wood are plausible. and all decay. The arithmetic had to be solved before departure. There was nowhere dependable at sea to replace the water. Food was easier. Dried fish, processed plants, or other durable provisions could be carried, and more food might be caught along the way. A healthy adult can endure several days with little food, not without water. Then there was sleep. If the craft kept moving, travelers needed shifts. Someone watched direction while others rested, then woke the next group. If everyone stopped, the craft surrendered its course to the current, and an hour of sleep could undo hours of paddling. Without clocks, the sun, stars, moon, wind, and swell divided the journey. Rain could replenish water. A storm could swamp the vessel or turn it over. Choosing when to leave mattered as much as building the craft. In a modern model, this is called a departure window. In life, it was someone standing on the beach at dawn, reading cloud, wind, and water. Then saying, "Today." Every kilogram of cargo competed with drinking water, food, tools, repair material, and perhaps a way to make fire after landing. The exact manifest is gone. They may also have made room for objects with entirely social value. At Mandu Creek in Western Australia, archaeologists found 22 shells and fragments in a layer about 32,000 years old. Most had been pierced, hollowed, shaped, and smoothed into beads. Some show thread wear. This was not food waste, it was jewelry. A bead holds no water, catches no fish, and cuts no wood. Its value lies in meaning, status, kinship, origin, or ritual. Meanings do not fossilize. The bead does. The Mandu evidence is far younger than the first crossings, so it cannot put jewelry on the founding boats. It shows that Pleistocene people made objects valuable because others understood them. Survival is getting a body to the far shore. Migration is carrying a social world. Skills, memory, relationships, and identity. They carried what they needed to live. And in Sahul, they continued making things that told them who they were. The archaeology of this journey has a cruel bias. It shows us mostly the people who reached the far shore and survived long enough to leave evidence. Stone tools, beads, fish bones, and genetic lineages are not a logbook of the crossing. They show that at least some voyages ended in life. The ocean preserves almost nothing of the others. There is no known Pleistocene wreck from the route, no layer recording a lashing failing at night, no dating method for a group that vanished while land was still tens of kilometers away. Even reaching shore did not guarantee success. Bradshaw's estimate of 1,550 people is not a line between life and death. It is the founding size at which his model keeps near extinction risk low. Smaller groups could survive, but an early dry season, accident, or run of bad years could erase them. Groups may have crossed, found food, and had children, then vanished generations later, because too few people absorbed too much bad luck. The model cannot identify them. It shows history had room for them. The earliest successful crossings lacked what later voyages could accumulate: dependable knowledge from the far shore. Scouts may have returned before larger groups followed. Archaeology cannot recover the sequence. But the earliest movement could not rely on a charted route or generations of reports from the destination. A return may have been possible. No traveler could assume the same winds and currents would carry a boat home. Archaeology cannot recover a departure scene. It cannot tell us who argued, who volunteered, or who changed their mind at the water's edge. So picture one humanly plausible morning. Some people enter the boats, others stay. Repeated voyages mean not everyone leaves at once. Age, health, skill, and willingness decide who goes today and who watches from the beach. The travelers carry part of the community's future. Those remaining have no guarantee that news will return. There is no message from the far shore, no signal that the landing succeeded, no promised date when a sail will reappear on the horizon. They may never know whether a daughter crossed, a new child saw the far coast, or the boat vanished in a night without witnesses. For one traveler, a mother's face shrinking on the beach becomes the last image of home. For someone on shore, the vessel becomes smaller, then becomes a mark, then becomes nothing. That scene is a reconstruction. The danger is not. Maritime people needed no model to know the sea could take a vessel. They learned the cost of choosing the wrong day. Courage is not failing to see the danger. It is seeing the danger clearly and getting in anyway. So how did they cross the ocean? With vanished watercraft, fiber technology, fresh water, and knowledge carried in memory. By choosing favorable conditions, maintaining progress slower than walking pace, and reading direction from an ocean that looked empty to outsiders. Not by being fearless. Fearlessness would have been useless. Fear and preparation are not opposites. Fear tests the lashing twice and carries water for the day the voyage should already be over. The blank map from the start of this video is now in your pocket, complete enough to include a cafe review. But not one line drew itself. Every name on that map began with someone going to a place that did not have one yet. Nobody handed them a map. They are the people who drew it.